All right, happy Friday, folks, and welcome back to another broadcast from the bunker. Today's hot topic, glaciers. How do glaciers cause erosion? We have a new set of do now questions in the GC. Take a look. It's astronomy 8A, looking to do numbers 1 to 4. All right. Don't forget, tonight your CAS learning is due by midnight. This is the third or fourth day you've had on that, so make sure it is completed. I'm going to start to calculate grades this weekend. Makeup labs have also been posted on the GC. There are 4 of them there, so if you're looking to boost your grade a little bit and you have some red exclamation points for the missing labs, see if one of those 4 is one of the ones you're missing and crank that out. All right, get started on the do now. Be right back. All right. Here we go. Number 1, it says, as seen from New York State, the noon sun is. Well, we're going to have to do process of elimination on these for this type of question. Never directly overhead. Well, that is a true statement, right? In New York, the sun will never be directly overhead. We're too far north of the tropics. So far, that looks like it. Directly overhead every day? No. No place on Earth has the sun directly overhead every day. Directly overhead on the first day of spring and fall? Nope, that would be the equator that has that. Directly overhead only on the first day of summer? Nope, even on the first day of summer, we're only at about 72 or so degrees at our current latitude at solar noon. So, yep, got to go with choice 1. Number 2. Which statement best describes the geocentric model of our solar system? Geocentric, geo means Earth, so Earth at the center. All planets revolve around the sun. Nope, that would put the sun at the center. Earth is located, there it is. Earth is located at the center of the model. And back in the old days, if you thought otherwise and verbalized that, that could be jail time or even worse. So interesting times. All right, number 3. Which diagram shows the position of the Earth relative to the sun's rays during a winter day in New York State? So we're looking for winter in, the northern hemisphere. Your North Pole has to be tilted away from the sun. Well, the first one is tilted towards the sun. That's no good. This one, there's no tilt at all, must be an equinox day. This one is still tilted toward the sun, so I guess we're going with the last one here. And there it is, the North Pole tilted away from the sun, and that would be our winter. Okay? So got to go with choice D on that one. And number 4, based on the redshift data on galaxies, most astronomers infer that the universe is currently doing what? Well, redshift, remember, dealt with wavelengths, and if something's coming towards you, the wavelengths get compressed, and if something's moving away, they get stretched out. And when you relate that to colors on your reference table chart, which is right here, the red is the longer wavelength. So it's getting stretched out. Things must be moving away, must be expanding. And that's what that question's alluding to. If it was a blue shift, the wavelength would be decreasing and things would be coming towards you. And we said that that's would result in the big crunch. But the red shift is a result of the Big Bang, and that's your expansion there, and that's what's going on. All right, so expanding is your answer. This is known as the Doppler effect as well. All right, red shift and Doppler effect, similar thing there. All right, if you have further questions on that, leave me a comment down in the section below. Let's jump into the lesson. Okay, so like I said, today's topic's going to be glaciers. I called it a hot topic, but technically a cold topic. And here we go. Okay, a couple of beautiful pictures of ice in motion. Yes, ice does move, folks, as crazy as it sounds. Once again, remember, this is posted in your GC as far as handing in assignments. Please refer to this to get credit for your work. Okay. Anyway, did you all really know that we are Canadian? Well, there it is, folks. We'll talk about that in a second. Alright, what is going on there? What am I talking about? Pretty sure this was the United States. Yeah, glaciers have changed the landscape of the world, so to speak. And, well, I think you'll understand in a moment here. So here is a layout of the land. In New York State, transported soils are more common. Transported means soils that came from someplace else. More common than residual soils, and that's because of glaciers. Long Island was brought here by a glacier. Literally, it came down from the north, from Canada, and bulldozed all this sediment and stopped right around here at the end of the last ice age. Well, when the ice melted, all of that sediment stayed behind in this linear island that we call Long Island. So yeah, a lot of our sediments were pushed here from Canada, hence the Canadian national anthem. Okay. There were actually 2 episodes of glaciations they infer that caused Long Island, and that's why we have 2 different forks, right? 2 different tales from 2 different glacial periods. Okay, please read that through, little glacier info for you. And let's get into our notes here. Glaciers, what are they? How do we define them? They are large masses of ice slowly moving across the landscape. And can push pretty much any size sediment, right? Wind can only push, a certain size sediment. Water can push a little bigger than wind, but still it's limited. Glaciers can push pretty much anything. It's the bulldozer of erosion. And if you look at these lines here, they look like contour lines. You remember that elevation lines? Look at these numbers, folks. Okay? You're looking at Greenland and Antarctica, of course, here. And if you look, 3,000, that's in meters. That's how thick the ice is. That's amazing. Okay? Empire State Building is only about 330 or so meters tall. 1,000 feet tall. Well, this is thicker than the Empire State is tall by quite a bit. That's a lot of ice, and that's why they say if all this ice melted, sea level could rise as much as 400 feet, which is pretty amazing because the highest point on Long Island is only 300 plus feet. All right, check out this little animation here. How do they move? Well, you get a lot of snow up in the mountains often, and as that snow gets heavier and heavier and accumulates, the glacier comes down the valley, and it scrapes and carves and breaks the rock, and it cuts these valleys into not a V shape like a river, but a U shape. Well, it isn't always a period of warmth, right? We go from warming periods to cooling periods, vice versa. So this would happen during a cooling period, and during a warming period, well, you guessed it, the ice will start to melt. And when it does, they say it retreats, and it retreats back up the valley, leaving that U shape behind, a bunch of unsorted, scratched up sediments. And of course, you'll get some rivers that form as the ice melts. Many people in the world depend on glacial ice melt for their fresh drinking water for the remainder of the year, which is a concern, of course, as a lot of these glaciers are retreating in our warming period, that they'll run out of a fresh water supply, and that's a pretty major deal. Okay. Well, here we go. How do they move? They advance and they retreat. They advance when you get more snow than melts, and they retreat when you get more melting than you get snow. It's a natural process. It happens all throughout Earth's history. We are currently in a warming period, like we said, so the average glacial motion is a retreat. Okay? Sediments are left behind, just like the sediments we're standing on, pushed here from Canada we were joking about before. they're unsorted because the wind didn't blow them in this orderly fashion. The water didn't blow them and move them in this orderly fashion. A glacier simply pushed them all together. On the north shore of Long Island, we have these rocky beaches. On the south shore, as that ice melted and pushed some of the material downhill, which is south on Long Island, you ended up with more sand down south on Long Island. A couple of beautiful pictures there showing you glacier retreat, right? A lot more ice back in the 40s than today. This is showing you some more retreat, right? 2001, 2002, 2003, showing you how it's retreating in our period of warming. Okay. All right. Well, where is the fastest part of a glacier? It's the same for the most part as rivers. These arrows are called vectors, if you remember. The bigger the arrow, the faster it goes. Well, ice moves similar to water, just a lot slower. It'll be faster in the middle, right? On the sides, you have your mountains, and that ice will rub the rock and slow down, so it is faster in the middle. And it's also faster toward the top here because it's not rubbing the bottom. The only difference is with a river, it was a little slower at the top because of wind resistance, because it was going that fast. But ice is going quite slowly, so wind resistance is a negligible factor. All right, fastest at the center, just below, and slowest at the sides because of friction with the valley walls. Make sure you get this in your notes. The steeper the slope, the faster it goes. That's just like a river, right? Steeper it is. Eventually, you get a waterfall if it's steep enough. Okay. More beautiful pictures of glacial ice in motion. You can see it's not the purest of snow, right? It's not a white color because it's got a lot of sediments mixed in with it. All right. Funny Far Side cartoon. I don't know if there's any Far Side fans out there. Gary Larson. So just how fast did these monsters move? Well, the cartoon says, say thank, wall of ice closer today, no? And it might seem kind of funny, but they've estimated glaciers could move as much as several meters a day. So if this is during an ice age and this is an advancing wall of ice, well, then you can see by tomorrow, if they don't move out of their cave, they're not getting out of their cave. And that's the joke. They don't realize how fast it's going to go. But by tomorrow, that would seal off their cave. Again, that's Far Side cartoons, very funny stuff. All right, how do glaciers erode sediments? Well, abrasion is key, that rubbing, that friction, that grinding, because there's a lot of mass involved. And they'll be all unsorted. There'll be a lot of parallel scratches as the ice moves in a pretty much straight line. They'll have grooves. They'll be polished, right? When you rub something hard enough, you tend to polish it. And all of these rock types can be seen in Central Park. You can actually still see the scratches left behind in the bedrock of the exposed rock in Central Park. So hopefully this summer we'll be out of all of this nonsense. Head into the park and check it out. Okay. Look at these shapes. What letter are we seeing here, folks? Well, if you said a U, you're in good shape. Glacier, right? Reverse was V. Glacier is a U. It makes these beautiful U-shaped valleys. They once probably were river valleys, right? They had their V shape, but when the ice pushes through, it changes that V into a U. Okay. You also get these cool features. They look like duck heads. They call them drumlins. They're elongated hills of unsorted rock, right? Once again, glaciers are all unsorted. And they tell you the direction the glacier came from. So which way do you think this glacier came from, if you had to guess? Well, if you said this way, you're in pretty good shape, right? It came from this side and then it tapers on down. That's your flow. A little schematic from a profile here. That's a top view. You can totally see the contour line showing change of elevation. And there's a profile view side slope. Okay. Glacier is going that way. Now, it should make sense. It's coming from the north going to the south because it's colder in the north, and obviously glaciers come from where it's cold. All right? So when you see these pictures, you can usually tell which way north is because that's where the glacier came from. Okay? Okay. Beautiful picture right there. Look at all the colors mixed in, the blues, the browns, and you can see the scale, right? I mean, this guy's probably at least 5 feet tall, And that's a small valley glacier, but they're still enormous. All right, let's take a look at some summary questions here. The bedrock at a certain location is deeply scratched. That's a big clue. And in some places covered by unsorted sediment, another big clue. Well, what are we talking about pushed it here? Well, it certainly wasn't the wind or the water, right? It had to be ice, your glacier. Which diagram shows transported by a glacier? Well, you're looking for the unsorted pile, so that would be, of course, choice 4. Over here, it's asking you what agent of erosion created this. Well, look at the shape there. That's your dead giveaway, your U, right? Glacier. These are all classic Regents questions for glaciers. This was an experiment that they set up to see how fast the ice moved, and they first put all the pegs in a line, and they came back, over months and years, and this is what happened. They literally moved to this pattern, and you can see the one in the center moved the farthest, so it must have gone the fastest, and the ones on the side didn't move as far, so they must have moved slower. Right? You're not going to stand there and watch ice move. That's just not going to happen for you. Okay? So what is going on here? Well, that's showing us that the glacier is moving faster in the center than on the sides. Okay, finish it up here. U-shaped valleys, parallel grooves, characteristic of course, glaciers. Again, those are all classic Regents questions. They word it a little differently. They often use similar diagrams, so the more you see them, the better off you'll be. Look at that. That's called a glacial erratic. That was not put there by wind or by a river. That was pushed there by a monster force of ice. And if you see a giant boulder in the middle of nowhere, well, a glacier probably put it there in the past. They call those glacial erratics. Okay, it's funny. When somebody buys property and that's in the middle of the property, they usually want to get it out of the way, so they'll have to pay somebody to blast it or move it. And then other people want these giant things in their property, so they'll pay somebody to bring it in. Classic case of the grass is always greener, right? All right. Well, there it is, folks. If you have any further questions, please leave them down in the YouTube section below, or, of course, shoot me your questions on Remind. And once again, as far as your grades for the end of the quarter, please refer to that slide on how to properly submit your work so that you can get credit and get the nice grade that you deserve. All right, folks, have a great weekend. I'll see you soon.